Hi people, it's Chandler Klebs here, and I'm recording another video, but this one's a little bit different. I used to do a lot of programming years ago with QBasic, C, C++, Java, just toying around, following tutorials, trying to learn some things. I never got very far with programming. But recently I found some of my old JavaScript code from 2013, so I thought, hey, I'll try to get back into JavaScript. Because JavaScript I would have to recommend as a first programming language. And that's because you don't have to install anything. Because if you have a web browser to be able to even see this video, whether it's Firefox, Chrome, Internet Explorer, then it will run JavaScript. And so using Google Chrome to run my JavaScript program that's embedded in an HTML file, I have been messing around. I've written a few programs here, and so I'm going to try to show you in this video the programs I've written. 3 of them, and 2 of which are kind of the same thing but slightly different. Okay, so I'm going to go to recording my screen. Hope that this works. Okay, so now here's the thing. Here is my JavaScript folder, and I have 4 things in here. One of them is an example from Wikipedia that I copy pasted, so I'll just show you that. This is an example of a weird thing from Wikipedia, and my browser's loading. That always takes a little bit of time. So let's see, once it fully loads, see how there's a button that says hello, and then when you click it, then the page says hello world, and then it adds some text here, and every time you click the button it adds that. So that's one I stole from Wikipedia, basically. Just copy pasted that. And also in every web browser there's a way to view the source of the page. So when you see that, it shows the source code, and that's a very simple one. But basically that's how you can view the source of any page. But then also I can of course just view the source code in Notepad++ of that. So that's just that's a basic example. And I modified the example because it included all these tags. I basically copy pasted everything, but then I wrote my own code in the script tags for my other things. So the first one I wrote here was factors.html. So this one, what it does is it creates an array with 100 elements. And how it works is it creates an array and then it filters out all the composite numbers. Well, actually this one displays how many factors every number has. And the prime numbers are the ones with exactly 2 factors. So if it has more or less factors than 2, then it's composite. Otherwise, if it's exactly 2, it's prime. So that's the thing is it works. And I'll just show you the source of that real quick. It's not that big. It all fits on one page, and so that's really cool. Okay, and then basically, so that's one thing. Interesting. So now, I will also show you the primes one, which is the second one. Basically, the prime finder is the exact same code except with one slight difference here. See how it displays all these prime numbers? When you look at the source code, that is because of the fact that there's an if statement here. If the x element of the A array equals 2, then it writes it. So basically, it will only display the numbers that have exactly 2 factors, but all the rest of the code before that is identical. So there's the prime finder, and a prime finder is, that's a task for many people, really, because prime numbers are not that hard to find once you understand the math behind what makes a number prime or not. Now this one is my latest one, power2.html, and you'll soon see why. See this? The powers of 2. And what's interesting, notice that the title says Chandler Clips Powers of 2. This is my proudest achievement right here, guys. I have written this program. I did it in QBasic when I was like 14 years old, and then I've done it in C, C++, which are kind of similar. I did it in Java, and I've done it in JavaScript before, but I lost access to all my source code with the exception of the things I found in an old file on my hard drive. So here's the thing. See, we have starts at 1, 2, 4, 8, 16. See how this works? And notice how many zeros there are? That is all customizable by editing the source code. So what I'm going to do is I'm going to open the source code in the text editor, because you got to see this. This is freaky stuff. This it's basically an HTML file, and there's the title. The title decides what the title of the tab is in the browser. And I've been trying to add comments to my code, because you know that's good programming practice, adding comments to your code so people can understand it. Not that anyone will understand this unless they're a real nerd, but hey, you know, it may help me understand what I was doing here. Okay, so basically, let me go through this line by line. But before I do, let me make sure that my recorder's, okay, yeah, it's still recording the screen. I really hope this works. So first, I declare my 3 favorite variables, and that's because of the X, Y, and Z coordinate system in Minecraft. That's what inspired me to start using these as my variables. Okay, and then A for array. A is the first letter in array, so that's why I use it. And besides, it's at the beginning of the alphabet, and the other ones are at the end of the alphabet, so why not, you know? Now, here's length. Length is set to 128, and this is important because if you look at this, if I delete the 8 and make the length 12, then see what happens. I reload the page and notice something. It only displays exactly 12 digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can customize how many digits it shows, including all the zeros. Now there is a way to make it not display the extra zeros. However, then they don't end up lined up. Plus, you actually have to add more code to make it detect where the beginning of it is, either keeping track of it with a variable or searching through the zeros and finding the first non-zero. So this way, I like it for artistic reasons, how they are all lined up nicely, and also just because the code's smaller. Okay, so, and as you see, it still keeps doubling the numbers, and yet it doesn't display all the digits. So here's the thing. So, for example, I could set it to 60, for example, and reload it, and then, yep, we're at 60 digits, which is a lot less than the original 128, but it's cool. In fact, if I'm not mistaken, this number only needs 20 digits. So let me change the length to 20. And basically, you can just modify the length to however many digits you need with this program if you have the source code. So this one is perfect here because the last one here, 2 to the 64th power, is exactly 20 digits long in decimal form. Now this program doesn't do other bases because the only bases that matter in my opinion are binary, decimal, and hexadecimal. Binary and hexadecimal because they're using computers, and decimal because that's what humans use, even though it's not the coolest base. So what I'm going to do, however, is I'm going to set this length back to 128. Now I'm going to show you something else. I can change, now this one here, this number right here, that determines exactly how many powers of 2 it displays. So Z is 0, and while it's less than or equal to this number, the loop runs, and Z gets added 1 each time. So if I set it to 16 and then run this, I'll just reload the page. See how it only displays up to 2 to the 16th power. I'm going to delete these other tabs here. I don't need them right now. So yeah, that's 2 to the 16th power. And I can do 2 to the 32nd power. And these numbers are actually very significant, and that is because like if you're at 16 on a 16-bit CPU, this is like the highest number, actually slightly higher. Like it's actually 65535 is the highest integer in 16 bits, whereas this number is 2 to the 32nd power. And on my old computer, which was a 32-bit processor, like this was this number minus 1, where it ended with a 5, was the highest number for an unsigned integer variable. Like if you're programming it in C or Java, then that you have to understand how many bits numbers can be. However, what I have done here, the brilliance of my Powers of 2 program, is that it doesn't depend on your CPU actually. You just need a computer that has a web browser with JavaScript. So, for example, if I set this to 128, let's see, did I remember to save the file? Okay, I want to make sure I save the file, and then I reload it. We'll check this out. Now it goes all the way, it goes way freaky. 2 to the 128th power. I kid you not, this is some weird stuff. I can technically keep increasing this. Like, this is just insane that this even works. But yeah, it will perfectly double the numbers. Oh, I didn't even know the page reloaded because it's that instantaneous. That is so cool. So what you see here is that there is 2 to the 256th power. It's absolutely outrageous what we see here. And I mean, you can make this much bigger. You can make it, I can make it even millions of digits. However, at a certain point, a human can't read it. So what I'm going to do here is I'm going to set this number back to 32. Because for the most part, people are only concerned with numbers that are up to 2 to the 32nd power. So let's see. I might still want to explain how this works. Okay, yeah, I have time. I have to leave for work around 9, so I still have some time to explain this program. And I'm very proud of this program because it's so cool. So as you see, this creates the array. This sets the length to 128, and this loop fills it all with zeros. It goes through every element, sets them all to 0, and then this one sets the element 0, the first of it, to 1, because it's supposed to represent the number 1 in the lowest place, in the ones place. Okay, and then this is the big loop. And this, I already explained this one basically, the master loop. This is how many times everything else between it runs. So I'm just trying to make the code look a little prettier here. This is the output loop. Right here. This, what it does is it starts at the end of the array. Now notice a.length. I could have just used length, but a.length is the automatic length of an array, because JavaScript, just like Java, keeps track of how many elements there are in your arrays automatically for you. So I didn't even need to create this. This is just for the purposes of showing people that. Okay, and so what it does is it uses document.write. Now I've read that that this is bad programming practice for JavaScript, that you shouldn't use document.write anymore. However, this is for the sake of example. This is not meant to be a professional modern thing. This is just me showing off that I can write a Powers of 2 program in JavaScript. So document.write was good enough. So what it does is it starts at the end, the highest order, higher number places in the decimal system, basically, and then writes each one. So it's writing them backwards so that it looks correct. And then at the end, document write the BR tag, the line break. And it's bizarre how HTML works, but this is how you make a new line. So that's very important to know that, is if you are writing things in HTML, or if you're doing a JavaScript program like I am, that's a very important tag to know. In fact, this program doesn't use any other official HTML tags besides the ones included, the standard HTML, body, head, title, all that. Anyway, enough about HTML. This is where this right here, this loop here is the heart of everything. Y is used as the carry variable. I didn't write a comment for that, but I can explain it in this video anyway. And so what this does is, oh, I need to delete this comment. This comment was from when this was still the prime program. So what this does, it's a binary left shift to multiply by 2. And a left shift is a quick way of just shifting the bits in a number to multiply it by a power of 2. In this case, I'm multiplying the number by 2. There's more than one way to double a number, but this is my preferred way. So it's adding it to itself. Just think of it that way. Now what this does is this, after it doubles the number, then it adds y, which is the carry. And if you've ever done addition on paper, you know what carry means. So basically, here's how it works. This would not work without this if statement. If that particular digit is greater than 9, it won't fit into a single digit anymore. It sets the carry to 1, and then it subtracts 10 from that digit to delete the extra 1. And otherwise, it sets the carry to 0. So what happens when it goes to the next digit and doubles it, then it will add the carry to it so that everything looks right, the same way as if somebody was literally doing the old pen and paper addition method themselves. So this simulates how you do addition. And so if you don't know how to do addition because you're still in preschool, then basically you won't understand this. But I'm enough of a math nerd that I know how addition works, that I basically just made a repeated self-addition program. Wait a minute, I messed this up. Yeah, see, what I'm trying to do here is I'm just trying to make the code look a little bit prettier here. There's a preferred style that I like to use. And actually, I should have done this beforehand. I really should have. But I'm going to go to the preferences, and then I'm going to look at how do I change the font size in this program. I'm using Notepad++, and this is like really cool, but I cannot figure out how do I change style configurator. Okay, I'm going to need to remember this. Global styles. Ooh, my font name is Deja Vu Sans Mono. Let's see what happens. Let's see. Ooh, fixed system. Oh, that's a weird looking thing. It's a little bit harder to read though. Okay, whoa. Oh, freaky. Okay, let me set this to 12. Oh man, there's all kinds of like weird. Oh, cool. There's like all these cool different fonts I can use. Whoa. Okay, so let me just go back to what I had before. Okay, where was I? I was at okay, here's Deja Vu Sans. Ooh, and that looks terrible. See how terrible that looks? All of my indentation is lost. Okay, I'm going back to Deja Vu Sans Mono. I must have set that years ago as my font in this program. So what you see now is I can adjust the size of the font to make it as small or big as I want. So what I'm going to do here, let's see, there's a font size of 10. I'm going to set the font size to 12. And then I'm going to save and close this. Okay. So now I figured out how to change the font. So here's the idea. Basically, I'm going to, let's see here. I'm going to remove just a few lines here. Basically, I can move some code on the same line. Since this is all about output, I can totally just put that all on that line. And then I'll just put this little comment over here at the end. See, I'm a perfectionist, and so I'm like really weird about the way my code looks. So, okay, so let's see here. Yeah, see this that F is there, but I want an indented one. Okay, so there is the loop for the output. Now this loop is a little bit more complicated, and so I'm not going to collapse it into one line like it did for the other, because I think it's important to yeah, it's important to see these individual steps. And then add the carry. Okay. And then I already explained everything. So here, this looks pretty good. I'm thinking I will keep it like this. Let me see here. I like the look. I could remove this extra space here, but I like to have this loop separated from everything else. So I'm going to do that, and then I'm going to do that. Okay. Everything here is the setup. Everything here is the initial setup, and then this here is the important thing. Okay, and I have no idea why this part is always highlighted, but it always is for some odd reason, and I don't know why. Yeah, that's just the tag for the doc type thing that's HTML. Okay, so basically, there we have it. There is my source code, and hey, I know what I'm going to do. I'll move the cursor down there, and then I'm going to screenshot this. I may use that as the image that displays on this video. And then over here, I'm going to reload the page, and it's okay. Yeah, sure, this is a little bit ridiculous because I have more digits than I need, but hey, it looks kind of cool, so I'll screenshot this as well. And I think that's it for this video. I've been able to show you my source code, and I may also consider publishing the actual text file of the source code if you're interested. So anybody, if you're interested in just downloading the source code, then that's totally fine. So basically, yeah, just leave me a message in the comments if you want me to like email it to you, or maybe I can post a link somewhere, because it's plain text. It shouldn't be too hard to share. Or you can type it all in yourself from the screenshot. But that's, that takes time. So I can give the source code to anyone who wants this. I mean, it's open source. Yeah, I'm just very happy that I've succeeded at rewriting my old Powers of 2 program. This is just like the ones I used to write in QBasic back when I was 14 years old, and I'm 30 now. So I've done programming but on and off through the years, and I find it very exciting. In case you can't tell by my voice, like I get all excited because I'm like a major math nerd. Kind of like how I get really obsessed with exactly how many blocks wide and tall my structures are in Minecraft. Like, I'm a math nerd, and this fits into my video games, Minecraft and Terraria. I'm super picky about how many blocks wide or tall something is. And I'm an artist too, so I care about numbers. I care about how many sides there are on a polygon. But hey, I'm autistic, so what can you expect, I'm a major computer and math and video game nerd, and I guess that's all there is to say about that. Anyway, hope you've enjoyed. Bye.